Physics 2212, Lab 1, Charge Tapes. The purpose of this lab is to prepare two pieces of charged tape and observe their interactions both with each other and the surrounding environment, such as a pen. The models used to represent this are a physical charged tape system and a computational system based on physical experiments taken in the lab. This lab successfully determined that the charge on each tape was determined to be 4.2 times 10 to the negative 9th coulombs, and the number of electrons lost by the tape is 2.0 times 10 to the 9th electrons. This lab uses three key concepts. The first of the concepts is Newton's second law, which states that the net force on an object is equal to the change in momentum for that object over time. This is shown by the formula. The second key concept is Coulomb's law. Coulomb's law allows us to find the force of attraction or repulsion between two electric charges, using the formula given. The final key concept for this lab is the gravitational force near the surface of the Earth, which is represented by negative mass times gravity. In this case, gravity is 9.8 meters per second squared. Some key assumptions we need to make for this experiment are that the tape behaves as a point charge with the charges located at the center of the tape to simplify equations. Each piece of tape needs to have the same total charge despite tampering, and we need to neglect air resistance. For the experiment, we have the system as tape B and the surroundings as tape A and pretty much everything else around it. The initial conditions for this are the length of both tapes is 0.2 meters. The tape is given a positive charge, as we found by putting it against a negatively charged pen, and the mass of the tape is 0.00196 kilograms. For the actual experiment, we suspended tape B between two objects and held tape A under it, which acted as a point charge, until it pushed up on tape B. Then we measured the distance between tape A and tape B when tape B was being pushed up, and we used that distance for our calculations. To start my calculations, I first found the gravitational force on tape B. The gravitational force is mass times gravity. In this case, it's 1.96 times 10 to the 3 newtons. Next, I found the separation distance when tape B floats. That was 0.009 meters. Next, to find the charge on tape B, we know that the electric force on B is equal to the gravitational force on B. Using the equation, we can find that Q is equal to 4.2 times 10 to the negative 9 coulombs. Using this, we can find the number of electrons by taking Q and dividing by the charge of a single electron. We found that there are 2.63 times 10 to the 10 deficient electrons. Using this as well, we can find the ratio of electrons over atoms. We can use the length of the tape of 0.2 meters and divide by 10 to the 10th, which is the length of an atom, to find that the tape has 2 times 10 to the 9th atoms. If we take our deficient electrons and divide by the number of atoms, we get 13.125. This is the code I made in GlowScript to model the experiment. At the top we have constants such as gravity and the length of an atom, then the data from the experiment such as the tape length and the tape mass, and the calculations that I did on the previous slide, just put it into Python. And finally we have the model to visualize the experiment. As you can see in the top right, there's equal force pushing up and pushing down on the tape B, which pushes it up. The values found by the Python script are almost identical to what I found in the calculations page. Some possible sources of error for this experiment are the charge on a piece of tape can fluctuate easily depending on the environment. The distance at which tape B begins to float may not be entirely accurate due to human error. Treating the tape as a point charge is a generalization and could also the final answers, and the charge on tape may not be evenly distributed across the entire surface. If the electrons had a positive charge and the protons had a negative charge, the observations we had in the lab wouldn't be very different, because like charges would still repel each other. And why is it important to handle the charged tapes as little as possible? As you begin to handle the charged tapes, it gains back electrons as it comes up in contact with your hand or another object, and this causes it to change back to its neutral state, which makes it lose charge.